we use Brewster method because we need to focus. Okay? What is focusing? Focusing means, actually speaking, we keep the object at infinity or at principal focus. Technically, okay? You forget about all that. Physically, why do we focus? So that we get a clear image through the optical device. Now here starts our problem. Through the optical device. But here we have one instrument with two optical devices, the collimator and the telescope. And both of them have to be focused. Because both of them have to work as a team. You imagine a situation where you are driving a car. The car has only one steering, and that one steering, controls all the four wheels. But you imagine when you turn your steering towards the left, what should happen? The two front wheels have to turn towards the left. Now you imagine the situation: you turn your steering towards the left, and your left wheel turns to the left, and right wheel turns to the right.
Chassis will be easy.
Now I don't know all that, but I know one thing is those at least one wheel will come off, and your car will stall, and you will be literally on the road, car down. Right? Because they are not working as a team. Okay? Or you imagine that you are having a chariot. Okay? You've got two horses, and one horse turns left, other horse turns right. Both have run away, and your chariot and you are on the ground. Okay? Now, the moral of the story is both these optical devices should work as a team. And for that to happen, we have to perform a procedure called Schuster's method. Okay? Fine? Now, what is the Schuster's method? It's a very, very, very simple thing, and I don't understand why students hate this experiment and hate spectrometer. I'm not speaking about you, Anisha. I'm not speaking about you.
So I love spectrometer.
Okay, good. Thank you very much. Should do it. Okay?
Common ground, sir.
Okay. Now, no, I'm not speaking about it, but in general, spectrometer students take. And then they start loving it in device. I don't know whatever. All across the system.
That was magic, sir.
Okay. Now, what is our situation? You consider that this is the crosswire, and you consider that this is the yellow line. Okay? You brought the crosswire to the turning point of the yellow line. Right? Okay? Now, suppose you release this and this is locked. You look through and do that same process again. What is happening? The yellow line comes here and goes back. It's as if it is hitting the crosswire, not reality. It's as if it is hitting the crosswire and going back. Right? Okay. So this is the extreme point, the turning point of yellow. Correct? So now what you do is, it is here. It is never going beyond this point on the right. It is only going on the left. What you do now is, keep this tight, turn this knob, and move the crosswire 1 centimeter to the left. What I said? You move it 1 centimeter to the left. The correct way of saying that would be, move it 1 centimeter in the direction in which the yellow line goes out. Why I am saying all that is, suppose I have kept this side and the clamp was that side, all that you have seen would have been reversed. Okay? But here we will just say, move the crosswire 1 centimeter to the left of the turning point of yellow line. Okay? Now, what is 1 centimeter? Don't go and ask me for the meter scale.
No.
You have to imagine that one. You look through, imagine this structure 1 centimeter. Fine? Okay. Now we are ready for Schuster's method. Okay? Very good. Now what you do is, bring the yellow line to the crosswire. Earlier the crosswire and the yellow line were together. You moved the crosswire by 1 centimeter by turning the tangential scale. Now what you do is, you bring the yellow line to the crosswire. How you will do this? You will do this by turning the circular disc. But when the circular disc turns, the prism table also turns. When the prism table turns, the prism turns. Correct? So, I'm not looking in, I'm just turning this. See, I am now turning this. I am now turning this. Well, when I turn it this way, the angle of the prism. What is the angle of the prism here? The angle opposite the opaque surface. This is the angle of the prism. So when I turn it this way, the angle of the prism has turned towards the collimator. When I turn it this way, the angle of the prism has moved towards the telescope. Okay, fine. Now, when you are doing this, now when I am doing this, it is perfectly fine for me because I am looking at this directly. No, I am not looking through. For you, it is even more simpler because you are nicely relaxed, sitting or standing and looking at me and listening to me, right? The problem starts when you look in. Problem starts for me when I look in because I can't look at that. I am looking at the yellow line, right? So how do I know what is turning? How do I know which side it is turning? Very simple. You agree that all of this is 360 degrees? Okay? Telescope, collimator, right? This is one angle, this is another angle. Okay? Everyone will agree that this is the smaller angle. Everyone will say this is the bigger angle. Right? Which hand do I use? I will use the hand which is on the side of the big angle. Okay, if this were all this side, I would have used my left hand because this should have been the bigger hand. Now I use my right hand, and I am not bothered about what is happening there. I am only focusing on my hand and the yellow. Okay, sure. Now, since I am using my right hand, why am I using my right hand? Because on the right side is my bigger angle. Right? What will I do? Now my situation is like this. When I look through, my situation is like this. Whether I turn that side or I turn this side, my yellow line will always move this way. Right? So to bring it here, I either move my right hand this way or I move it this way. But I should remember what I mean. So I'm human, I can make mistakes, I'll make a decision straight away. I will bring the yellow line to the cross wire by moving the angle of the prism towards myself, towards the telescope. So I'll move it this way. What am I doing? I'm looking through, this light will be off, okay? I'm looking through and I'm slowly, very slowly going to move it this way. What will I see? I'll see my yellow line coming to the cross wire. Will it stop there? No. Where does it stop? It stops on its own only at the turning point that is here. So when it reaches here, I stop turning. I stop turning my hand. Why? Because I want to stop the turning. I want to stop the yellow line there. Why? Because the cross wire is from your reference point. Okay, what have I done? I have brought the yellow line to the telescope, to the cross wire by moving the angle of the prism towards the telescope. When it reaches over here, focus the telescope. When it reaches over here, you focus the telescope. Why focus the telescope? Because you move towards the telescope. Okay? Now next, we have a touch back. Right? Don't be in a hurry to touch. So what do you do? Now you turn towards the collimator. Same right hand, it will now go away from you. So what will happen? What will you see? Watch here. It will go. Stop for a moment. You are still moving. You are still moving your hand. You don't stop. You continue turning that side. It will come over here. Will it stop? No. You have to stop. What have you done now? You have brought your yellow line to the cross wire by moving the angle of the prism towards the collimator. Focus the collimator. Okay, how will you focus the collimator? Will you put your head here? No, just put your head here. Telescope is a viewing device. So you look here and with your left hand you focus. Right? Okay, now what do you mean by focusing? Focusing means the yellow color that you get becomes narrow, sharp, and clear. Narrowest, sharpest, clearest. Okay, so it's quite possible that it was this wide, When you brought it here, then it becomes narrow, it reaches here, don't worry. But you have to keep it narrowest, sharpest, clearest by touching this knob and this knob. Okay, first you did this, then you did that. Correct? You will check now. Is this okay? I don't know. So, I now have to look at this. How will I look at this? Again, look through this. Move slowly backwards. What will happen to the yellow line? It will move towards the turning point. It will stop for a moment. You are still turning. You are turning. The line has stopped. It will come here. When it comes here, you stop. What have you done? You have brought the yellow line to the crosswire by moving the angle of the prism towards the telescope. Now watch. Look at the yellow line carefully. Is it clearest, or do you need to make it more clear? Do you need to make it narrower? Don't say this is enough for me. No. No, it has to be the best. Otherwise, you have a problem with reading later. Okay? If you need to focus it by focusing this. Now, if you don't need to focus it, Schuster's method is done. If you need to focus it, you focus it and then go to the other side. The moment you touch one knob, you have to check on the other side. You keep on doing this collimator, telescope, collimator, telescope, collimator, telescope, till finally you don't need to focus. Then Schuster's method is done. Okay? If you are lucky, you may be done within 1 and 1 trial. If you are unlucky, you may even need 50. You need 50, 100,000, do it that many times. Otherwise, you'll never get proper results. Okay? Now comes the volcanic eruption part. Why I tell you not to touch over here? When you touch over here, the focusing is disturbed. So to redo that entire set. Not even by mistake should you touch here. Don't bang your eye, your head, your forehead, or whatever else. Guard it. Okay? Otherwise, you repeat the whole thing. It's not possible. Okay? Now, are there marks for this?
No.
Depends
on the.
Depends on how you see.
Yes.
Okay?
If you are the.
How is it? How is the question paper? First sentence will be adjust the spectrometer for parallel light. That is Schuster's method. Okay? Examiner will most probably not come and check that. But if you have not done it properly, examiner comes to know at any point of time in the experiment, and forget about the examiner knowing or not knowing, you will not get grades. It's like saying, we paint the walls, right? We whitewash walls. Has anyone ever whitewashed the foundation of the building? Have you seen the foundation of this building? I have not seen. It was very much before I was born. But could they have said, Brewster is going to be a PY student who is going to complete it in 2020? Okay? Why do you have to put a foundation? Pratiksha will not see it. Pratiksha will come to college in 2017 and she will be early 2020. 50 years, 60 years from now.
Yes.
Pratiksha will never see. So let's build a building without a foundation. Let the building last. No? So system method is the foundation of the structure. If you don't do it, you are finished. If I don't have the foundation, I don't have anything. Okay? Now, you should practice. Do it now. Okay? And your experiment starts after Schuster's method.
Yeah.
We are not doing the experiment.